Alright, welcome back. Let's talk about orthogonal functions. In previous video, we see an analytic description of periodic function. So this one we'll be looking into orthogonal function. Now, what are orthogonal functions? A function is said to be orthogonal on an interval a less than or equal to x less than or equal to b if the integral going from a to b of the first and second function multiplying themselves with respect to x are equal to 0. That is, two functions f of x and g of x. Two functions f of x and g of x are said to be orthogonal on an interval a less than or equal to x less than or equal to b if the integral going from a to b of f of x multiply g of x with respect to x is equal to 0. If this condition holds, then we can conclude that f of x and g of x are orthogonal. So let's take an example to illustrate orthogonality of a function. The question there says, let f of x be equal to x and another function of x, g of x, be equal to 3x squared minus 1. The question there says, show that the functions are orthogonal in the interval minus 1 less than or equal to x less than or equal to 1. So the interval there is just telling us that we have to integrate from minus 1 to 1, just like this interval here. We have to integrate from a to b. So let's go ahead and see if this function will give us 0 on integrating from minus 1 to 1. So we have given that f of x is equal to x and g of x is equal to 3x squared minus 1. So it's very easy. Just substitute into the formula and integrate. So we have the integral from a to b of f of x multiply g of x will be equal to, with respect to x, will be equal to the integral. If you should compare, you have that a is equal to minus 1 and b is equal to 1. So we are integrating from minus 1 to 1 of f of x, which is x, multiply g of x, which is 3x squared minus 1 with respect to x. So if you should multiply out, you have the integral from minus 1 to 1 of 3x cubed minus x dx. So let's integrate this function. Very easy. If you should integrate 3x cubed with respect to x, you have 3x to the power of 4 over 4 minus, if you integrate x, you have x squared divided by 2. You take your limit from minus 1 to 1. From minus 1 to 1. So let's go ahead and substitute our upper and lower limits. So we are going to have 3 into 1 to the power of 4 over 4 minus 1 to the power of 2 over 2, okay, minus, substitute the lower limit, you have minus 1 to the power of minus 1, sorry, 3 into minus 1 to the power of 4, 3 into minus 1 to the power of 4 over 4 minus 1 to the power of 2 over 2. So let's evaluate and see what we have. All right, so we have this. We have 3 into 1 to the power of 4 will give us 3 over 4. So we have 3 over 4 minus 1 to the power of 2 over 2 1 over 2 minus, because 4 is even, so minus 1 to the power of 4 will give us 1. So we have 3 over 4 minus, because 2 is also even, minus 1 to the power of 2 will give us 1. 1 over 2. So we have 3 over 4 minus 1 over 2. Use minus to open the bracket. You have minus 3 over 4. Minus times minus will give us plus 1 over 2. So if you observe carefully, we can collect like terms. We have 3 over 4 minus 3 over 4 minus 1 over 2 plus 1 over 2. And of course, this is equal to 0 plus 0, which is equal to 0. So since the integral from minus 1 to 1 multiplied by, since the integral from minus 1 to 1, x multiplied by 3x squared minus 1 dx gives us 0, then we can conclude that the function f of x and g of x are orthogonal. So therefore, f of x and g of x are orthogonal. Alright, thank you. In the next video, we are going to look into the Fourier series coefficients.